Good morning, good afternoon, or good evening, depending on where you're tuning in from today. And thank you for joining this TechStrong Learning Experience with Harness. My name is Tip, and I'd like to welcome you to our TechStrong Learning program. This session will be available afterward on demand. We will also be sending you a link to the recording after we conclude. Please send your questions to the Q&A panel on the right side of your screen, and join us in the chat. By telling us from where you're tuning in from, share your experiences, your comments, your understanding of the matter. We want to hear it all from you and engage with you. Any questions that we are not able to get to today, we will follow up with you shortly after the program concludes. Now, let's kick off today's topic, database DevOps, fast database changes with performance and compliance. Thank you everyone for joining us today. We have Martin Reynolds and Mick McGinnis joining us today. Martin, can you take it from here?
Hi and hello, welcome everybody. So today I'll be presenting with Mick. My name's Martin Reynolds and I'm Field CTO at Harness. And Mick?
Yeah, good. Hi everybody, Mick McGinnis. I'm the co-founder and product manager of DB Marlin.
Awesome. So we're going to jump right in here today and kind of set some of the problems and then talk about hopefully some of the solutions that we can drive out about how you can do things better. So, one of the things that I know from personal experience is that database changes slow everything down. And, historically, I've worked with incredibly complex databases with relational databases with hundreds of tables. And every time we did changes, it was a big deal. On top of that, making sure we maintain the data and, often delaying feature releases because of the complexity of the database. Should be easier. And, in this day and age, we like to do everything as code, right? So why not databases? Why don't we deliver databases as code? So there we go. So just to kind of summarize some of the challenges that we've seen, because of database changes slowing things down, realistically, if you look at the way things often work in organizations now, and certainly a lot of the organizations that I've spoken with and ones I've worked in historically, is that, a developer makes a change to the database or writes a change to the database, and ultimately that needs to go to some database team or database administrator just to review that change, make it sure it's sticking with the standards. To do that, that normally gets put in a spreadsheet maybe, or a Jira ticket or a ServiceNow ticket, and then you're kind of stuck, right? You can't release that thing because it's dependent on the database change, and you're waiting for that database change to be approved and happen. Then ultimately, eventually, somebody looks at that, maybe rewrites it, tweaks it, optimizes it, and then finally says, okay, you're good to go, and release it. Problem is, historically, certainly for sure, my experience of releasing database changes was running a lot of SQL scripts manually, and having potentially somebody from the DBA team as part of the deployment who's actually got access to those databases and run those changes. And one of the risks of that, obviously, is, humans make mistakes, not intentionally, but they do make mistakes, and so it adds risk to that whole process, and again can slow it down, can potentially cause performance outages or just general outages, or even data loss. All of those things, ultimately slow down delivery and slow down the speed of getting features out. And often these days, we're told we should be able to deploy all the time and make those changes quickly, but it's hard when you have a database that is slowing everything down in the background. So DB DevOps, what is it and how do we do it? So, DB DevOps essentially makes the database changes part of the whole process. So part of the pipeline deployed alongside, your application, whether that's a web front end or a service, is deployed in the same pipeline. It's done with speed, kind of like almost like GitOps for database, and because it's in a pipeline, you can then govern that, make sure it has appropriate stage gates, approvals at the right places, maybe apply some policies and some code quality to it to make sure it's meeting the standards of the organization, and also it gives you much better visibility of those changes. So, actually being able to, see all the changes that have happened, where they've happened, which environments they've happened in, and then, beyond that, being able to track the impact of a change post deployment, which is actually where I'm going to hand over to Mick, where he can talk about, what happens when something's deployed and how you get visibility inside of there.
Great. Thanks, Martin. So for those that don't already know DB Marlin, so it is an AI-powered database observability solution. And it's aimed not just at database administrators, but it's aimed at DevOps engineers, developers, SREs, and basically anybody these days that needs to get deep visibility into their databases, which is many different roles these days. So first of all, at the core of the product, we're monitoring the performance of the databases and all the activity going on within them. And we're doing that 24/7 with 1 second granularity, which means you can basically look at what was happening in the last minute and see second by second, or you can go for longer periods like the last hour, day, week, month to look at longer term trends. Or you can get very specific and zoom into a time range of interest, maybe because it was when you deployed a change, or maybe it was because you had an incident, and see exactly what was happening within that time range. The next thing we do within DB Marlin is we bring in change information. And from day one, we've included change information in the product, because having worked in this space for more than 20 years, we know the most likely time you are to have a performance issue is when you've changed something. And that change could be a code release, it could be a parameter change, it could be an infrastructure change, or it could be a schema change. And for certain types of changes, we're able to auto-detect those. So for things like database parameter changes and schema changes, we can auto-detect those because we're connected to the database, so we can see when those happen. And then for other changes, we're able to link with CI/CD solutions such as Harness. And so you can see here an example where it's highlighting that there was a Harness deployment using database DevOps at that point in time. So I'll show you this in the demo later and get into more detail. The other thing we can do is we can alert when performance degrades. So here there was a degradation. It happens to coincide with a change, but anytime database performance degrade, you can get alerted. And those alert notifications can go to things like Slack, ServiceNow, PagerDuty, or just email. And then when you get into the analysis side of DB Marlin, where you're trying to then identify what the problem is and crucially how you can then fix that. So first of all, we can get a breakdown of the time spent within the database and where that time was spent. So in terms of the wait events, that would show you where the database is spending its time. And we can apply either our knowledge base or our AI copilot to give you some guidance around what you can do to optimize these things. And then similarly, you can identify your top statements. These are your most resource intensive queries. And you can see how much time each of these queries is consuming and what their weighted contribution is to the overall database time. And again, you can apply the AI copilot to those as well. So for this top statement here, you can see the execution plan, and then you can also get into some recommendations like the one highlighted in red here, which is a suggested index to improve the performance here. And if you don't want to use the built-in copilot, we now have a bring your own LLM feature where you can just generate the prompt and then send it to any AI of your choice. And then next we get into the validation of that change. So having made a change, whether it was just a regular change as part of your deployment schedule, or whether it was an optimization that you applied using an AI recommendation, or whether it was just something that you tuned using your own knowledge, you can then use our comparison reports like the one that you see here. And this is looking at top 10 statements before the change and then the same top 10 statements after the change. And you can see performance has improved there. As well as integrating with CI/CD solutions, we also integrate with a growing number of full stack observability tools. So you can see the logos down the bottom here, some of the ones that we were able to click through from. And the way this works is when you're looking at a trace within one of these tools and you see that that trace is slow because of a database statement, you're able to click and then click into DB Modeling to see the database performance perspective for that statement, and again, get the AI recommendations. As far as platform support, you can see the 10 different database platforms that we currently support, and this is a growing list. But for any of these, you're able to get a nice consistent view of performance and change across these. And we support all of these both self-hosted in your own data center or your own cloud, or cloud versions of all of these, including database as a service. So things like Amazon RDS, for example, or Azure SQL, we're able to monitor them. So basically anything you can connect to, you can monitor. So I'm going to hand back over to Martin now, and he can take you through a demo of Harness Database DevOps.
Yeah, hi. So I'm back. And the way I'm going to do this is I'm going to kind of talk through some of the principles of database DevOps and then kind of tie them into the overall process. So, you know, what I've got here is I'm starting with the code, right? I'm going to make my database changes as code. This is an example change log of the code. And here you can see I've got, you know, an ID against every change. I can see who the author is, what the context is, the comments. This particular one here, I'm adding a column, and obviously my rollback action is to actually drop that column that I created as an example. And, you know, why do we do that? Well, you know, you can, obviously that means that your every database change is versioned. You can manage that through that version number. And you can also do things like have different branches that represent dev, QA, or prod. So, you know, the second part that I talked about when I was talking about, you know, what makes good DB DevOps is actually talking about how that integrates into the pipeline and so deploys with everything else that you have in your application. So here, what we have is an example end-to-end pipeline where you've got everything from build and test to, you know, pushing those artifacts up and going through the environments of dev to QA. And then after a final actual approval, going into production. And you can see in this pipeline here, there's a whole bunch of activities that are happening, you know, including, you know, security scans and, you know, updating JIRA tickets and everything else. The key one here that seems quite small in this process, but I'm going to show you it exploded in all the stages it goes through in a second, is that DB schema apply, which is where it's essentially going to take that change log and apply it for you in that environment, alongside rolling out, in this case, the containers that make this part of the application. And interestingly enough, if I go into the, you know, the QA environment, it does exactly the same process and again, the same in production. So what I'm going to do is I'm going to go to a version of this that's run already so we can, I thought I had a screen prepared, but apparently I moved off it. So I'm going to go to one that's executed already. So here what it's done is we'll go to that deploy to prod, and we'll come back to the red, why it's red in a minute. But essentially, if I scroll across, what I actually get in here is a kind of an exploded view of what actually happens during that process. So those first little bits is just initializing the runner and getting the code base, so getting that change set from the code. And then actually what it's doing here is it's importing those change sets. So in this particular environment, the production database, it was already at version 16, and the change it's going to make right here and that it's adding in is this change 17. Now I'm going to pull this over a bit so we can get a bit more visibility, you know, which includes when that was deployed and, you know, what the Git commit was associated to that, so that we can actually see everything there. Now, you know, so we can see what's going to change and what's been applied. And then in here, if we go to that next step, the preview and validate. So let's talk about preview. What that actually does is it takes that database change that you created in your YAML file that says, hey, this is what we're going to change. I want to add, in this case, what it's going to do is it's going to lock that database, and then here's the update database script. So I actually have visibility of what it's going to do. So it's going to use the database, it's going to alter a table, it's going to insert some audit information to say that it's been updated, and it's going to remove that lock on the change there. Now, the other thing it does at this stage is it does validation, which, we mentioned about having good governance over it. And one of the ways it does that is, this one, is it actually goes in and, will run a policy against it that says, here's some things that you're not allowed to do in your changes. In this case, we're saying, hey, for all of our databases, we don't like people to drop databases, drop schemas, or drop tables. And the reason we don't do that is because we don't want to lose any data. So, we have a policy here. This is just a sample, very simple policy, but it's saying in production, you can't drop any of these things. And if you do, we're going to block you. So part of that stage that we were looking at right there in that kind of preview and validate is it saying, hey, you're not going to do anything that's not allowed in production. If that policy will have been broken, it would have actually stopped the execution at that point, and nothing, the application and the database would not have changed. So, beyond that, it does some tagging and ultimately then applies that schema change that was done and tags the database with the version. Then we kick off and we go into the rest of the application deployments. Now, what you saw here is that you've got this continuous verification stage, which is something where essentially we would take data from your application logs, like, maybe Datadog or New Relic or whatever tool you use for monitoring, but we'd also take, your application logs and definitely take in data from DB Marlin to be able to say, hey, do you know what? We've executed this and we're looking at how it's running in the kind of, the post 15, 30 minutes. And we've determined that there's a problem. And Mick's going to show you how we can, then drill into the details of that to see what the problem was. And then based on that, we can actually then, roll back those changes or keep them in place. So, in this case, it's decided to automatically roll them back. And down here, it's gone back. And you can see, that it's ultimately it's ultimately rolled back the schema for us and taken it to the previous version that it was before, and then updated some Jira tickets to say it's all not gone well. And part of that database update and rollback is actually making sure that DB Marlin knows that we've actually done that DB DevOps change and maybe updated the application too, so that it's fully aware of it. Now, the last little thing I want to show you is, I mentioned visibility is often a problem and understanding what changes have happened where. So, you saw that deployment. It had successfully, it said that the database was at 16. Here we have, we've got one database schema. We've got 8 database instances. Now that's actually 3 pre-production instances. We've got like a dev, QA, and a staging. And then we have, multiple region deployments for the production system. And here you can see that while POP 17, the latest change, did successfully go into dev and it went successfully into QA and staging, what it didn't do was successfully go into production because it failed that deployment and failed that rollback. So you've got, very clear visibility for your database and your database schema. Obviously, we support multiple schemas if that's what you want to do. But, it gives you really quick and easy visibility into what the status of any database in any of your environments, because it's fully environment aware. Now with that, what I'm going to do is I'm going to let Mick take over and let him show you how you could solve that performance problem that made the application roll back.
Okay, thanks, Martin. So I'm going to run you through DB Marlin and how you can use some of the features here to track the impact on changes and how you can use some of the AI features that I mentioned to optimize database performance and queries. So on this top level screen that you can see here, you can get a view of performance over any period of time. So at the moment, We're looking at the last hour, and we're seeing performance across a variety of different instances. And you can see from the icons here, it's a mixture of different technologies. Out of those 10 that I said that we support, you can see we've got a number of them represented here. And for each of the instances, then we've got, to the right-hand side, we've got our key performance metrics. So starting from the right-hand side, you've got average response time of any SQL statements run against these instances. You can see a measure of throughput, so the number of statements executed within the time range that we're looking at. And then the total resource usage, so how much time in total was the database busy running all of these statements. And then moving across, you then have our events columns. So alert events, which means that we detected there was a performance issue during that time range. And then these two columns here are different types of changes. And I mentioned there's two sources of change events. The ones that you see in this column here are changes that we auto-detected to things like database parameters or schema objects. And then the ones that you see in this column here are custom events that have come to us through the DB Marlin Events API. And that's how tools like Harness would integrate with DB Marlin. So what I can do, I mentioned earlier that we can get very granular at looking at time ranges, and we can specify a time range either using the date control, or what we can do is use a snapshot. So a snapshot is basically just where you give a name and description to a period of time. And if you say keep the data, you can lock that data away for as long as you need it. And then you can recall the snapshots from a list here. So I'm just going to go into this snapshot here, which is the one that I prepared for the webinar. And this is looking at a period of time from earlier today, 7:14 to 7:48 this morning. And I'm going to go into this top instance here because you can see that we had some auto-detected changes and some custom events. So we click in, you then get to the instance level dashboard, looking at this Postgres 16 instance. And you can see the green, which is the database time. It was quite high during this period, but it actually started off quite low. And then some things happened here around 7:30. And that database time has suddenly increased and stayed high throughout this period here. And because we're bringing in the change information, you've got that context there automatically, where if you mouse over on these icons that are showing on the timeline, you can see, first of all, at the top that we triggered an alert there because the database wait time increased above a threshold. You can see we've got a couple of auto-detected schema changes because we're connected to the database. We automatically saw that those two indexes there were dropped. But then using the Harness DB DevOps integration, you can also see we've got this other event down the bottom, and it's actually referring to a particular pipeline and build ID here. And it says you can click to the events tab to see more details on that. So if we do that, you can now see this Harness DB DevOps deployment is actually got a clickable URL. And if we click the link, it takes us in context then into Harness, into database DevOps, and into that exact job and build number that you saw there. So this is back to what Martin was just showing about how you can then start to look at the different steps for that deployment. If I just go back to my activity screen again, I just wanted to show you a couple of things. So first of all, this performance problem here, we didn't do any automatic rollbacks, and we weren't using continuous verification. But if we were, we could have done some verification, maybe 10 or 15 minutes after this deployment, seen that performance had gone bad, and then trigger the automatic rollback. So that could have been fully automated without any intervention at all. In this case, we didn't do that, so we can see performance is still bad here. So now we want to use DB Marlin to actually troubleshoot what's gone wrong here and what can we do to fix it. So we can break down the database time in a number of different ways. So one of the most common ways will be to break it down by statements. And you see these stack bar, which each of the different colors now represents a different statements. So you've got 4 of them, which seem to be the ones that slowed down as a result of that deployment. And you can see the same 4 statements represented as a ring chart, and you can see the same 4 top statements here, top of the list on our statements tab, and you see how long each of those has taken. The other thing you can do is you can go to the weights and see which database wait events has increased as a result of that. And we're spending more time in active, buffer IO, data file read, buffer mapping in this case. And we could send those to our Copilot and get some recommendations around those if we wanted to. Let me just show you that quickly. So the Copilot is a slide out panel. It's available on every screen within the product. And we have specific integration points like the one there where you can just click a button, and without you having to do any typing, it automatically sends a prompt to the AI, and it came back with some suggestions here saying you need to optimize your queries and consider indexing and so on. And this is a chatbot, so you can type follow-up questions if you wanted to. So that's one way we can get some AI recommendations. The other way is when you actually get down into an individual statement. So if I click into the top statement here, I've now got the statement and I've got the plan. We capture these plans automatically around the time when the statement ran, and we keep the history of them. So in this case, during this period, we've actually got two different plans. We've got this one, which is the lower cost plan, and we've got this one, which is the higher cost plan. And that's because what we saw was, there was indexes created and dropped during this period, and that's caused this statement to flip between these two plans. So given this is the non-optimal plan, we could also send that to the Copilot. And again, without having to type anything, it's generated a prompt that looks like this. And that's including the statement text and the execution plan and the technology type in there. And if you give that a few seconds now, you can see it's come back with some recommendations. And number one is index optimization. And it's suggesting that the index that's on there isn't very good and that you want to consider indexing on these three columns here. So the pickup date time, passenger count, rate, code, which are the things that you see in the where clause and the group by over here. So then if I just go back up a level, go back up to the activity screen, so yeah, you can then obviously take that and you can deploy that optimization, or you could choose to roll back depending on which you prefer to do. Something I wanted to show, just going back to our events tab quickly, is how you can launch into our comparison reports. So for any of these changes that you see here, like this one, if you click the button over here, it lets you launch either the activity comparison or statistics comparison, and you can choose a period of time before and after the change event. So if I go for 15 minutes, this is going to look 15 minutes either side of 7:30, which is when the change event happened. So if I do activity, you can see we get a report that looks like this. And this is the 15 minutes before the change. This is the 15 minutes after. You can see average response time has got a lot worse. Throughput's dropped. And you can see clearly from the charts that the wait events have increased and the statement response times have increased. And then we can go even down to the statement level and see the percentage degradation on each of those. So that was one of the comparison reports. We do also have another one, which is the stats comparison, which is similar, but giving you a slightly different view on performance. And again, you can see clearly that performance before the change was good, but after the change is much worse. So using this, you could then decide to roll back the change. So yeah, that's basically how you would use DB Marlin to basically get to the root cause of any problems using the AI to get some recommendations, and then how you get the change events here onto the timeline from Harness as well. And as I said, if you were using the Harness continuous verification, you could have automatically triggered a rollback, so that wouldn't have required any kind of manual intervention here at all. So yeah, with that, I'm going to hand back over to Martin, and he can run through some key takeaways, and then we can open up for questions.
Sure. Let's load those slides back up. So, before I dive into the key takeaways, I will say, having tried to build this stuff myself in the past, and including getting detailed database monitoring, into something that I could understand. I would say these are all just solid principles you need to do this and do this well. And then beyond that, you can do them faster and quicker with us. So in terms of, the key things that you need, though, you need that version management. You need to be able to have that database configuration and database changes as code, documented versions. You need to be able to orchestrate those database changes along with the rest of the changes in your application at the same pace, right? So it needs to be part of your pipeline. And we showed that earlier, that it's all part of the pipeline, and allowing it to be fully aligned with the database changes, with the application changes. It needs governance over it, right? What you don't want is to slow down the process, because it needs to be reviewed by multiple DBAs or by a DBA team. And then if you can actually automate as much as possible as that, and control who can do what through good RBAC, then you can free up some of that resource of reviewing, and automate good practice and good style guidelines in terms of how those changes happen and what gets released into your environments. And then visibility, and I'm actually kind of overlapping visibility and the deep performance insights, if I'm honest, because having visibility of what's changed is super important, being able to do that quickly. But having that kind of deep insight into the impact of the changes you have made is like a game changer, and being able to track those and see where it is. And I know being able to resolve those and use AI to do it is a super powerful way. Those two things combined are really really empower that kind of database DevOps journey overall. One thing I would say, and I know Mick didn't show this, but it was something he mentioned when we've been talking about this, was that kind of ability to say, hey, here's a snapshot of what the database looked like when this happened, and I can go back to that snapshot, which is great for kind of going back and seeing that kind of historical view. And I love that, and it makes part of that journey much more visible. Maybe even link that into the Jira ticket that said, hey, this failed and somebody needs to look at it. So I think there's a bunch of really good things. You need to combine them all together. Those principles apply regardless. We just wanted to show you how we do it together, and can accelerate that journey to DV DevOps. I'm not seeing any questions right now. And if that is the case, I might go to the next slide. So Mick, do you want to talk through the left hand, and I'll tell you the right?
Yeah, so we have a promotion that we're running at the moment. So that means anybody using Harness Database DevOps already, which you can now get a free license to use DB Marlin for any one database instance of your choice, any of the 10 supported platforms. And that comes with full support as well. So it's a fully supported license there for anybody that wants to take advantage of that. So yeah, just click on the QR code and that will take you through to the website.
I love the little hand animation that came up then. That was very cool. On the other side of that, we have the DevOps Modernization Summit, which is just a free virtual summit that is coming up, where you can hear more about DevOps modernization. We have people like John Willis speaking, who was the author of the DevOps Handbook, AWS on there, Booking.com. There's a series of great speakers talking about how they modernize their DevOps processes. Scan the QR code and come along. I think with that, I think we'll both say thank you very much, and hand back to you.
Perfect. Thank you. Before we close out, if you all can please click the survey in the resources section, as your input is invaluable to us. Your feedback does go a long way here, so please do let us know about that or any other closing or final thoughts that you've got. Once again, you will receive an email in your inbox shortly after we conclude today's session with a link to view it. I would like to thank Martin and Mick for an insightful webinar and for taking the time to join us. It's been a pleasure having you. Thanks for joining this TechStrong learning experience. Looking forward to seeing you all again. Have a great day.
Thank you. Thank you.